Hi everyone, welcome to one more live session of WeBuild-AI. Today we're talking about three AI-powered private equity use cases from concept to production grade. We'll talk about uh, private equity use cases from competitor analysis to DDQ question answering. I'm Diogo, founding AI engineer at WeBuild-AI. My background is in data science, machine learning, shifted more towards generative AI, and currently I'm helping big enterprises designing and implementing AI solutions, enabling AI and communicating with their data through AI. Today, I'm joined by my colleague Stylianos. Stylianos, tell us a bit more about you.
Yes, hi everyone. My name is Stylianos and I'm a principal AI engineer here at WeBuild-AI. I design and deliver applied AI solutions for enterprise clients, helping organizations improve how they work with complex data and the workflows. And in this engagement, I led the technical architecture and implementation of the legal knowledge workflow, DDQ, as we say, and that's the one I will be presenting today.
Thank you. Thank you. Before we get into the use cases, would like to give us a quick word on who we are. So we build AI. We are a London-based company that what we do is simple to say, but very hard to deliver. We build custom, compliant, and production-grade AI solutions for enterprise organizations. The three words that really matter here are custom, because off-the-shelf AI not always fit the purpose of business. Compliant because in the fields we act, the industries like financial, energy, utilities, security is an option, and production grade because our products are not just for demos. We work to deploy to production. As I said, our customers vary a lot from different industries, from in the energy, financial services, investment, and yeah, happy to talk about the use cases. Before before talking in depth about the use cases, we are talking about private equity, and everyone knows that runs on information and speed. The ability to know more faster and better than your competitor is a big advantage for every company in this business. But behind every investment decision, there's enormous amount of manual, repetitive work that nobody talks about. And today, we will talk about three of the big real problems that we help solve in this client from private equity where we built three AI use cases, but production systems that are running today. And the pressure was removed from the deal team and legal team to move on quicker and faster. So the first use case we are talking about today is the automated competitor analysis. For this use case, every year this PE firm needed to answer a critical strategic question: how are we positioned in the market compared to our competitors? Specifically, what is the size and profile of companies we invested in compared by the biggest competitors we have? To answer this question, someone in the team would have to work through the financials of approximately 1,200 companies, and yeah, that's really a long work and manual work, repetitive work. This process took around 3 weeks and could only happen once a year because of the effort put into. The data challenge here was significant. The financials weren't always publicly listed in a clean format. For many companies, for all the companies, you need the VAT to then proceed to search for the financials in the right databases. But sometimes the VAT numbers are in different positions of company website or not even publicly available. You have to go to the company's house website to find them. So it's very hard to gather this information to then proceed with the next step of gathering the financials. Once we had the financials fetched from the third-party data source, filtered and corrected about with the right criteria, we then visualized in specific charts to generate a final report for the company to the team to analyze. 3 weeks of effort every year, meaning the team that was always looking at a snapshot that was already happened months before, or actually the year before. So to solve this, our first approach was to let these, as everyone these days is trying to solve everything with LLMs, let's throw these at an LLM. Give the list of companies and ask it to research and extract the VAT numbers, and then proceed to extract the financials, apply the filters, and finally produce the output. So, as most of the times happened with the LLM, with these complex and big data, it broke. First, the context window was overflown. 1,200 companies worth of data is enormous. LLMs have a limit to how much they can hold in working in memory. The model simply couldn't process everything together. Second, and more frustratingly, unreliable data extraction. Even when we broke the problem into smaller chunks to work around the context issue, the model would still extract financials from wrong fields, apply filters inconsistently, and confuse similar data points. With this amount of data, even a small error rate it grows fast. You cannot build a strategic report on this shaky data. This is an important lesson for everyone, and something that we grew with, and something that we now pass to all our customers. LLMs are not databases. They are not good at precise, large-scale structured data extraction, especially when accuracy is non-negotiable, as in for these investment deals. We had to rethink the architecture entirely, and instead of trying to do everything with the LLMs, we separate concerns clearly. What LLMs are bad at: precise data fetching, filtering, structured extraction. We handle this deterministic code with deterministic code and direct API calls. What LLMs are good at: generating format, coherent output. We kept it with the model. So the final system uses two different agents with distinct rules. One for the data collection that iterates through the 1,200 companies. It uses a custom web scraper specifically to find the VAT numbers because off-the-shelf tools weren't reliable enough for this job. It then uses the VAT number to query the third-party data source and then get the financials. The filtering logic runs programmatically. So not much LLM involved at this stage, just precise, reliable code. Then finally, the chart generation takes the clean, structured data, full suite, and using the exact same visual template the team was using, the continuity method. Stakeholders immediately recognize the output as their report because we were using the same branding quality. So now I will show you what how this works in practice. Let me bring up, and we can see the run here, where we just upload two documents containing the deals and the information that we need to. And you'll see that this will run a different number of steps, proceeding from extracting all the information to then visualize the information. So first you see the description of the steps, matching the companies, processing stake filterings, splitting companies, and then searching the VAT numbers for each of the company. And then after that, we will proceed to search the financials for each of the companies. This is the sixth step. And the final step is applying the filters corresponding to the financials that we can see happening in just a second. So from this, you can see that was generated, the output was generated, and finally the charts were generated in the right hand side. You see the charts generated consistently and according to the branding of the required use case. The results of this use case are enormous. We moved from 3 weeks process to 5 minutes. The accuracy was validated at 100% against the historical data from previous years before going into production. Now running in production, this use case is now running in production, and perhaps most importantly, the team can now run this analysis multiple times a year, not once. They are no longer working with annual snapshot. They can track the market positioning quarterly or in response to a specific market event. That's fundamentally different from a relationship with their own data. They can now proceed to use their own data more accurately. So the second use case we are here today to talk about is the company research. So picture this: a senior partner at this PE firm is in the back of a cab, 45 minutes away from first meeting with the prospect company. They message the deal team. Can someone send me a quick briefing on this company and their leadership before I land? Because I just came from this other meeting. The deal team answers, we haven't had the time to prepare that report yet because we had been preparing the report for the other meetings. This wasn't a one-off. The standard company research report covering financials, headcount, leadership team, recent news, strategic positioning took around 2 hours to produce. That's 2 hours of someone's day aggregating sources, formatting, every single time that the new prospect company came into scope. The report itself was very good. It was just a matter of the timing. And the bottleneck was the aggregation of this data. And there was a subtle but important issue, some naming conflicts that could come up with companies that would have similar names and then would produce some conflict in creating the report. But for this, when there was no time, the meeting happened anyway with incomplete information in the deal making. That's real, clearly a real risk. So for this, we built a solution that consists of four agents sequentially, deployed as a simple chat interface similar to the one that I just shared before, and that most importantly is accessible in any device, including mobile. So how does it work? The first agent does the company identification, takes the company name from the user input, resolves any ambiguity, and confirms the correct legal name before anything else runs. Second, the financial data collection connects to the third party data source to gather the financials from the database, to pull the structured financial data such as revenue, EBITDA, headcount, corporate structure, and the leadership team. The third agent uses a web search tool to search the web for recent news, press releases, leadership changes, and key people, surfacing what's happening right now around the company and the team. Finally, the fourth agent is responsible for report generation, takes everything collected and writes the report using the exact same template the team used and already trusted. Same structure, same sections, same tone. The whole thing runs around 2 minutes. It can be triggered from a phone, mid-commute, while in transit, as I mentioned before. And we the technology behind this is orchestrated with autogen, which gives us fine control over how the agents end off tasks to each other and handle failures gracefully. The models that are running are GPT 4.1 through OpenAI or Azure OpenAI, which means that the data never leaves the cloud environment of the PE firm, which is something that is highly non-negotiable for industries like the ones we work with. And a question that we get asked is why we broke it down into four different agents instead of just one big prompt. Um, this isn't just good practice and something that everyone is seeing now with model behavior. It's something that makes the output more reliable. A single prompt trying to do everything would just hallucinate, skip steps, get confused. The separation of concerns is as important as it is in AI as it is in software engineering. We'll see now a demo for this video as well, for this use case as well, and I hope you can see my screen and you'll be able to see these. I'll just type Ferrari as a company, and the first agent proceeds to search the web for Ferrari companies and possible conflicts. Gives us just Ferrari itself, and the user just types confirm that that is the company looking for. Then we proceed to search for the VAT that will be used for searching the financials. We then see the financials gathered as a data source, and finally after that the rest of the workflow proceeds to gather more information about the leadership, about the releases, news, and before proceeding to generate a greater report about it. The value of this workflow, this use case, is instead of taking the main one is time again. The same output used to take 2 hours to proceed this final report, as you can see here, and now it took 2 minutes. The value of this is the deal team is no longer the bottleneck before these high-stake meetings. The partner can gets a full briefing before they walk into this meeting, because it uses the team's own template. Trust in the output was highly, and finally, because it runs on any device, the value isn't tied to being at the desk and only using the computer. So these were the 2 use cases I had to present to you today and to share with you today. I will now pass on to my colleague Stylianos to proceed with the next use case.
Yes, thanks. Thanks for that, Diogo. Actually, now that the audience is like expressing their mind, should I ask you a question that I have for one of the workflows instead of?
Yeah, of course.
Okay. So for the first one, the competitor analysis, you said first you tried some other things with the LLM and you dumped things there, and the first approach failed on the and quickly you had like how quickly did you realize it wasn't going to work, and what made you confident that the second approach you chose would?
Yeah. That's a very good question. So, in this case, it became clear pretty quickly within the first serious test run. Initially, we were test with subsets of the data, and that was fine for the LLMs because the data was not enormous. But Then, as soon as we tried the first serious test run, the context window issue was almost immediate when we tried to process the full data set. But the more frustrating failure was when, as I said, when we tried to break it into small chunks and still kept failing. So the moment we realized was being the LLM was being asked too much, it like to behave like a database, we knew we had to change the approach. So once we drew a hard line, deterministic code handles these, the model handles the output, everything became much more stable. And with stable, you get the confidence from the output that you get, deterministic output. For the financials. And with the confidence came from that separation of concerns. Each part was doing what was supposed to actually do and what was good at. So we could actually test, perform more recurrent tests and regression tests with the separation of concerns.
Yes, I think this is a universal learning through all the
Mm.
workflows. Sometimes, yeah, this Gen AI has some limitations. Usually have to break it down to more deterministic parts. But yeah, thanks for that, Diogo.
Thank you.
Now let's move to the next workflow. We do not have a demo for this one because of the sensitivity of the data, but we do have a couple of slides. So yes, I want to share first of all a practical example of how AI can support the legal teams working in private equity firms. So again, we can start with a situation that many organizations in this industry will recognize. You have an investor that sends a question about their rights under the limited partnership agreement, or else LPA. And the answer is somewhere in the contract, but the agreement is hundreds of pages long and structured in complex clauses. So a lawyer needs to locate the relevant provision, checks whether similar questions were answered in the past, interpret the wording, and then prepare a response. And this type of task is repeated, you can imagine, many times across the file of across the life of a fund and the different files. So it is important work, but it can also be very time consuming and difficult to scale, especially when multiple questions arrive at the same time. So in this project, we explored whether AI could help transform how legal teams access contractual knowledge, not by replacing completely the legal judgment, but by making the right information easier to find and reuse. And this operational reality leads to a broader challenge that many private equity firms face nowadays. So in private funds, the LPAs are the core legal framework that governs investor rights, governance rules, transfer conditions, and many operational processes. These agreements are typically long and highly structured. The legal teams regularly receive questions from internal teams or directly from investors. And answering these questions often requires, as I said before, manually navigating through the agreement or any past questions that we already have answers for to locate the relevant clause and confirm the interpretation. So over time, organizations accumulate knowledge in the form of previously answered questions. However, this knowledge is rarely stored in a structured way. And as a result, lawyers may need to repeat the same search process even when similar questions have already been addressed in the past, or even the search itself can be very time consuming. This creates several challenges. First, it consumes the valuable legal time that could be spent on higher value analysis. Second, it can lead to inconsistent responses depending on who handles the query. And third, it makes it difficult to respond quickly when large batches of investor questions need to be processed. and usually that's the case. From a business perspective, improving access to contractual knowledge can significantly enhance responsiveness, consistency, and operational efficiency. And to address this, we designed a use case focused on transforming the legal documents into a structured, a searchable, knowledgeable system. So the core idea behind this solution was to treat the LPA document not just as a static document, but as a source of structured knowledge that can be connected to historical legal responses. We created a system that links previously answered investor questions to the specific clauses that supported those answers. This effectively builds an institutional memory layer for the legal team. When new questions arrive, the system can first check whether a similar question has already been addressed. If so, it can immediately surface the relevant clause and prior reasoning. If no such knowledge exists, the system can still search directly across the agreement, so the LPA itself, to locate relevant sections. In this way, both existing legal knowledge and the underlying contract text become accessible through a single workflow. This approach allows legal teams to process questions more efficiently while maintaining full traceability back to the original contractual language. Importantly, the objective is not full automation, as we stressed in the beginning. The goal is to provide grounded, evidence-based answers that lawyers can review quickly and use as a starting point for decision making. So let's now look at how this workflow operates in practice. So the process begins with a structured input rather than a conversational interface. The legal team uploads a Word document containing a table of investor questions. Each row represents a query and may include other data like references to a specific clause or items. And again, this can be hundreds of questions in that document. The system processes each question individually. It first attempts to match the query against historical legal responses that have already been linked to particular clauses. Semantic similarity techniques are used to determine whether a comparable question has been answered before, after we have filtered, if possible, with any clause or an item that we have. If a strong match is found, the associated clause can be retrieved immediately, and this enables the reuse of existing legal knowledge and reduces the need for manual document searches. And if no sufficiently similar match exists, the system automatically performs a fallback search across the LPA document itself. The agreement is divided into structured sections, and the most relevant clause are retrieved based again on semantic relevance. And here is where we took advantage of the structured sections of how the document is made. These clauses are then used to generate a concise answer that remains grounded in the original contractual text and includes citations for verifications. To support this workflow at scale, we implemented a structured system architecture. Let's see that. So, at a high level, the architecture reflects a two-stage retrieval approach. The legal knowledge layer contains both the LPA agreement and historical legal responses that have been linked to clause metadata. This structured storage enables efficient knowledge reuse. When a new batch of investor questions is submitted, the system parses the document and extracts its query. If clause references are provided, they are used to guide the search process. So it's an intelligent searching process. The retrieval layer first attempts to match the new question against previously answered questions using semantic similarity. And if the similarity exceeds a defined threshold, the associated clause is reused and the answer. If no strong match exists, the system moves to a fallback retrieval stage that searches across the chunked sections of the LPA agreement. Again, the chunking is, as I mentioned before, is an intelligent chunking that we did according to the structure of the document. And finally, the response generation layer assembles the retrieved context and produces an answer that is explicitly grounded in the contract text. So citation mapping ensures full traceability back to the source clause. This architecture allows organizations to combine structured knowledge reuse with dynamic document search, enabling consistent and scalable handling of the legal queries. And this brings us to the broader implications of this approach. So, to conclude this use case, um, this use case illustrates how AI can improve the way organizations interact with complex contractual knowledge. The limited partnership agreements define the operational framework of a fund, but accessing that knowledge has traditionally required significant manual effort. By combining structured legal knowledge, intelligent retrieval, and grounded AI generation, organizations can reduce the time spent searching documents while maintaining legal oversight and accountability. For private equity firms, this means faster response to investors, more consistent interpretation of contractual terms, and the ability to scale legal processes as funds grow. So more broadly, it demonstrates how AI can move beyond experimentation and begin delivering tangible value in core business workflows. So to reiterate the theme that AI will not replace legal judgment, but it can significantly improve how quickly and reliably legal knowledge can be accessed. And yeah, this leads to the end um, of this workflow.
Um, thank you very much, Stylianos. Before jumping to the final key takeaways, I would ask you a question that came up to my mind is how did you ensure that the quality of the output was up to the standards of the legal teams for that use case?
Yeah, that's a very good question, and it's something that a lot of teams struggle with. How do we evaluate and how do we keep the client into the loop? So we ensured that the outputs met the legal team standards through an iterative validation process rather than relying on a single technical evaluation. So from the beginning, lawyers were actively involved in reviewing results and providing feedback on accuracy, clarity, and usefulness. We ran multiple feedback loops where batches of investor questions were processed. The generated answers then were reviewed against the actual contract clauses, and the retrieval and prompting logic was refined accordingly. We also focused heavily on grounding. So every answer had to be supported by specific clause citations, as I said. So legal reviewers could quickly verify whether the reasoning aligned with the agreement. So over time, this helped build something very important, like confidence in the system's reliability. And in addition, we tested the workflow on realistic operational scenarios, for example, large sets of investor queries, just to ensure it performed constantly under real working conditions. So the combination of the legal review, iterative improvement, and evidence-based outputs it was that allowed us to align the system with the standards expected by the legal team. yeah, I think that's
Cool. Cool.
everything.
Thank you. Yeah, thank you for your answer. That enlightens me. Yes. So we come to the end of the use cases and the key takeaways that we take from this session, and would like to pass on for the audience is that the context of the LLM can ingest the context the LLM can ingest is limited in terms of size and complexity. Something that we reiterated a lot during the presentation, that the LLM can do so much with the data that is provided, and sometimes it's better to use more deterministic approaches to reduce the size of the data to make sure that the results are achieved. A multi-agent approach will allows for a more reliable output. Instead of using just one big prompt for with one agent, it's more useful and accurate to break it down into separate and more structured, more precise, more concise prompts and agents that have very specific and detailed actions to produce. The AI value in legal workflows depends on the first understanding of the document structure, not just applying models to it. Human review remains a key control point. As Stylianos was just now mentioning, AI accelerates the knowledge access, but it does not replace the legal judgment, where it will remain eyepiece on this type of analysis, because the knowledge of the models is not there yet for the legal judgment, and you can see and differentiate the results of the LLM and the actual legal team when producing these documents. And finally, grounding AI responses in specific contract clauses is essential to maintain the trust and regulatory confidence, because otherwise the hallucination can produce results that will produce some untrustworthy results and contracts that can cause a loss in the investment team. Thank you very much to assisting at this live session. It was a pleasure to be here today with my colleague Stylianos. Was great. If you are ready to build your AI advantage, you can always contact us on the normal channels. You can visit our website, LinkedIn, and contact us. Thank you very much. Thank you very much, Stylianos, for joining me today.
Thank you, Diego.